Hi everyone, welcome to the Math 70 video on section 4.2. And in this section, we are going to be multiplying polynomials. So if you want a refresher on what polynomials are, check out the previous video, which defines them and shows you how to add and subtract. We're going to get right into multiplying. So there are different ways to multiply a polynomial, but I strongly recommend that you use the box method. This is similar to what's called a box method for multiplying like 2-digit or 3-digit numbers. So if you've done that before, it may be familiar, but if not, it still works really well. So I'm going to show you with an example. We're going to multiply x squared plus 7 times x plus 3. All right, these are both polynomials because they're powers of x added together. And I indicate that I multiply them by putting them both in parentheses. You don't always see the dot in the middle, but I use the dot for multiplication. So the box method starts by saying, how many terms do I have here? I have 2 terms in my first polynomial, and I have 2 terms in my second. So I make a 2 by 2 box. And I have this handy grid paper right here to help me. So I'm going to make a 2 by 2 box. Looks like a window. Then you write one of your polynomials along the top, x squared plus 7, and the other polynomial down the side, x plus 3. It doesn't matter which one goes on top and which one goes down the side. Now that I have these, so write the polynomials along the top and side. So make a 2 by 2 box when each polynomial is 2 by 2, but it could be 3 by 4. It's whatever the length of your polynomials are. Okay, write the polynomials along the side, and then you do each multiplication. This box here comes from x squared times x, which is x cubed. This multiplication here, 7 times x, gives me 7x. This multiplication here, x squared times 3, gives me 3x squared. And this multiplication here, 7 times 3, gives me 21. So you fill in the box by multiplication. And then the last step is add up all the terms in the box. So in this case, I have an x cubed plus I'm going to work my way down the polynomial powers. So x cubed plus 3x squared plus 7x plus 21. There it is. This polynomial right here is what you get when you multiply x plus 7 times x plus 3. That's all that it takes to multiply polynomials. The rest of the ideas here are what do you do when the polynomials look a little different. So I'm going to show you some examples of when the polynomials look a little different. But keep in mind, we're still going to use those 4 rules. So this time, let's multiply x to the 4th plus 7x squared plus 2x plus 1 times x cubed plus 7x. So now I have 4 terms. So I'm going to make my box 4 units wide. These are 4 double units. And then I have 2 terms, so I'm going to make it 2 double units down. All right, and now I have a 4 by 2 box. It's not a 2 by 2 because that first polynomial has 4 terms in it. And then I write the terms along the top and down the side. That's still the same. I do all the multiplications. X to the fourth times x cubed is x to the seventh. 7x squared times x cubed is 7x to the fifth, etc., etc. 7 times 7 is 49, x cubed, 14. Notice I have a 2x times a 7x, so I multiply the 2 times the 7 and the x by the x. So I get 14 from 2 times 7 and x squared from x times x. There are all my terms, and then I just add them all together. X to the 7th plus 7x to the 5th plus 2x to the 4th plus x cubed plus another 7x to the 5th plus 49x cubed plus 14x squared plus 7x. That's it, I'm done. But I happen to have a couple apples and a couple oranges. Right, I have like terms. So in general, we want to add those like terms together. The x to the 7th is the only one of its kind, but I have a 7x to the 5th plus a 7x to the 5th, which is 14x to the 5th. Then I have a 2x to the 4th, that's the only one of its kind. X cubed and a 49x cubed gives me 50x cubed, 14x squared plus 7x, and I'm done. If you take it slow and you follow these steps methodically, multiplying polynomials is pretty straightforward. Another example, what do you do if some of your polynomials involve subtraction, not just addition? For example, x cubed minus 5x plus 1 times negative x squared minus 3. Step 1 is still the same. I need a box that's 3 by 2. So I have 1, 2, 3, 1, 2. I make my box double big so it's easy to fit. I recommend you make your boxes easy enough. And we still write one polynomial across the top. But this time we have to be careful to keep track of the sign of the terms, minus 5x. Here I have a negative x squared and a negative 3. Sometimes I put the minus in between, but I think it's better to put it here. And then we just do the multiplication, keeping track of negatives. X cubed times negative x squared is negative x to the 5th. Minus 5x times negative x squared, the negative and the negative cancel, and I get positive 5x cubed. And I have a minus x squared. X cubed times negative 3 is negative 3x cubed. Minus 5x times minus 3 is positive, 15x. And 1 times negative 3 is negative 3. That plus right there is a little bit of a mistake. Normally I would just write a 15x, but it's better than accidentally writing a negative. Now we add or subtract all of them together. Minus x to the 5th plus 5x cubed minus x squared minus 3x cubed plus 15x minus 3. And again, we have like terms, this one and this one. So I'm going to end up with minus 5x cubed and then a plus 2x. Let me start over. Minus x to the 5th and then a plus 2x cubed and then a minus x squared plus 15x minus 3. One more example. And I am going to squeeze it here so I don't have to scan a whole extra piece of paper. But I can do that because I'm going to multiply 2x squared times x cubed minus 4x plus 1. If it's just what's called a monomial, a single power of x, we often don't write the parentheses, but we're going to do the exact same thing, only now my box is going to be 3 squares wide, but only 1 square tall. But that's still okay. I can still make this box work. And there on the left side of the box is my single term. And I multiply them all together, I'm going to get 2x to the fifth minus 8x cubed plus 2x squared. And then I add them all together and I get 2x to the fifth minus 8x cubed plus 2x squared, and I'm done. So you can use the box method even when it just looks like a single term. This is the same as distributing across all three of these terms. It just uses the box to organize your work, and I think that's a great way to do it. All right, that'll end this video. Thanks for watching.